Hey everyone, today I'll be starting a new series where I go over common interview coding questions found on LeetCode and where I give detailed responses so that you could learn the question and so that I could also refresh on my coding skills. So today I'll be talking about a really common LeetCode question called two-sum. It's LeetCode question number 1 and the level of it is easy, so hopefully it shouldn't be too bad. I'll essentially be going over two approaches, one being the brute force solution and the other being the more optimal solution. So maybe we could get started and just read the question and then go through the solutions. So here the question says, given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. So essentially we get a target and we have to find the two numbers in the given array that adds up to that target. So in this case, 2 and 7, which are found in indices 0 and 1, would equal 9, and that's our target. Similar here, 2 and 4, which is indices 1 and 2, is 6, and here indices 0 and 1 are both 3, which when added together is 6. So to kind of go over this solution and maybe use like a brute force approach, I've kind of written the question here, and we'll kind of be going over one way that people might think about it. So one way is to kind of use a nested for loop, and that might be the easiest way that people can think of this. So just for an example, let me just rewrite the array, 11, 15. When you're first starting off, you may think that, okay, let me maybe just get the first index 2, and what's the best way to compare it to the next index? Let me just start another loop, but starting with so say this is index 0. Let me start off at index 0. Let me start off at index 0 plus 1, which is like 1 over here, and let me just kind of go through and see if they both add up to our target, which is 9. 9 would be our target. So we would see, okay, this one plus the next one is added to 9, and that's good. Say like the solution was in the middle of the array, so it's like say our array was maybe 11 and then 2, 7, 15. We would see that, okay, it's going to be, we're looking at index 0 and then we're looking at index 1, which is 0 plus 1. So then 11 plus 2 is not equal to 9. So then let's just increment this to the next one and then increment this pointer to the next one. So it's going to be then 1 and 2, which is going to be 9. And that would be our answer there. Like we would return 1 and 2, which is our solution. So that's kind of the brute force approach, just using that nested for loop and having 2 pointers. Let's maybe code that up and see what we get. So I'm starting off with our first for loop, which I'll call I as the pointer. And then for j in range, and here I'll do what I was talking about, where I do like I plus 1 or the current index plus 1, and then I will continue with nums. And next, all we have to check is if those indices match up. So nums I plus nums j to target, and then this is going to be an if statement. So if those two nums equals our target, all we have to do is return I, comma j. So this should result us in the answer we want. We could submit it. And yeah, we should see that it was accepted, but it only beats 16% of all the solutions that have been submitted on LeetCode for this problem in terms of runtime. And there is a more optimal solution. So going back to here, like we could see, like, well, I guess we could look at the code. We can see that each for loop is going to be a big O of n in terms of runtime. So essentially this runtime is going to be n squared because we have two for loops, so it'll be n squared since we're going through these twice essentially. So big O of n squared. Let's try to optimize this. Maybe get it to big O of just n, so that could be much faster. And to do this, let's kind of try the next solution, which is using a hash map. Okay, so what if we wanted to do this in a more optimal way? We could take advantage of something called a hash map, or in Python it's often called a dict or dictionary. And essentially what it is it's a key value pair where we have a key and then we have a value, and it's a quick lookup table that we can use, and we can easily get the values in O of one time. So in this case, our key we will use as the complement, which is going to be the complement or the difference of our target versus the index of our array. So this key is going to be our complement. And then our value is going to be the index of that element in the array that we just took the complement of with the target. So this will be the index. So using this example that we had previously, we have our target as 9 and we have our array as 2, 7, 11, and 15. If we create a hash map, what we can do is parse through the first element, so 2, and we are going to do the target minus the first element, which is 2, and we're going to get 7. So we can store 7 in our hash map, and the index is 0, so we will store the index here as 0. And then when we go to our next element at index 1, what we're going to do is we're just going to do a quick check if is this element 7 in our hash map, which it is, and if so, then we're just going to return the value of the 7 in our hash map, which is 0, and then the index of our element in the array, which is 1. So we got our answer here, 0 and 1. 2 plus 7 is 9. To look at this in a slightly more like complex example where the numbers aren't just the first two, we could kind of use a similar setup where our target is 9, but in this case we have some more numbers in the beginning, and then we have 7, 2, and then 15. So here we'll use a similar idea with the hash map, and we'll go to the first element at index 0, and we'll see that, okay, target, which is 9, minus 11 equals -2. Let's store that in our hash map, and let's put the value of this, the value of it is going to be 0, which is the index of 11. Next, we move on to the next element, which is index 1, and we see, hey, is 7 in the hash map? And it is not. So then what we will do is do the same thing. Do the target minus the element in that index, which is 7, equals 2, and we are going to store that in our hash map. So 2 with a value of 1 for the index. Then we go to index 2 here, and we see that the element is 2. So what we're going to do is, hey, is 2 in our hash map? And it is. 2 is in our hash map here. And so then, if it is, what we should do is we should return the index of that, which is 1, and then the index of the current element we're on, which is 2. And that is our answer here, 1 and 2, which is in the array elements 7 and 2, which add up to 9. So using this approach, we would essentially just need one for loop to iterate through the entire array instead of our nested for loop where we had to iterate through the array twice. And that would result us in big O of just n in terms of runtime, which is way more efficient than n squared, and definitely would be the more optimal solution. So let's code this solution up and test it as well. Okay, so for this solution, we would first need to define a hash map or a Python dictionary. And then we just need one for loop for I in range nums. And here we can get the complement equals, which would be the like I was showing here, it's going to be the target, like 9, minus the element. So it'll be target minus nums I. And now here we do our check, just as I was showing, if the number, like for example 7 or anything, or 11, 7 or anything is in the hash map. So if the number is in the hash map then all we have to do is return hash that value from that hash map, nums I, and the current index of the element in the array. So, like I said, 1 and 2, or whatever element indices they are. If it's not, it's fine. It'll just skip that statement, and all we're going to do is keep track and record the values in our hash map as we go on for however long we need to go on. So then what we're going to do is hash map complement equals I, and this should just store the complement just as I was showing, so that when we look and parse through our index, we'll check the complement and see what it returns. So let's submit this. And we see that it was accepted as well. And these results compared to our first brute force solution are way better in terms of runtime. We see that it beats 92.62% of most of the other solutions that are submitted, which is way better than our previous results from the brute force. And this is because we are only parsing through the element or the array once, as opposed to twice. So this would be big O of n. But overall, these are the two solutions. This was kind of like an easier problem. I'll definitely be doing medium to hard level ones soon. Hopefully you all learned a little bit of something, and good luck on all of your interviews. Thanks.